Now, in this video, we are going to take up one more problem on the projections of lamina. How to analyze this problem in 3 dimensions and also how to solve this by using the sketchbook. A rectangular lamina of 35 mm by 20 mm rests on one of its shorter edges. The lamina is rotated about the edge on which it rests till it appears as a square in the top view. The edge on which the lamina rests being parallel to both HP and VP. Draw the projections and find its inclination to HP and VP. So, to identify from where to start, as he says, the lamina is rotated about the edge. They rest on HP on one of its shorter edges. So, what does it mean? The shorter edge which is resting on HP has to be perpendicular to VP. So, since it is resting on HP, so one of the shorter edges has to rest on HP. So, all the shorter and longer edges has to rest on HP. So, since all the shorter and the longer edges has to rest on HP, obviously it should be parallel to HP. So, that means the surface inclination with respect to HP is 0 degree. Since it is surface inclination with respect to HP is 0 degrees, so that means it has to start from the top view because the true shape is seen in the horizontal plane. And also we can see that we have to start from the top view because the shorter edge, it appears as a square in the top view. So, this also indicates that you have to start the problem from the top view. So, let us analyze how it will going to be in the beginning. So, you can see this is the horizontal plane and this is the vertical plane. So, we have the shorter edge. The shorter edge is resting on HP, has to be perpendicular to VP. There are two shorter edges, one is AB and the other one is BC. Both are perpendicular to VP. Therefore, you are getting a point in the front view and also here. Here, ABCD is a rectangular lamina of 35 mm by 20 mm. So, as we look from the front view, both A and B is near to the observer. So, A dash B dash is visible and C and D is away from the observer. So, C dash D dash is invisible. So, here all the sides are resting on HP. So, therefore, you are getting the true shape in HP. So, the edge which is resting on HP has to be perpendicular to VP. So, BC and AD are the shorter edges which are perpendicular to VP and parallel to HP. Therefore, you are getting a point in the front view. Since the surface is perpendicular to VP, so you are getting a line in the front view. So, this is the initial position of the rectangular lamina which is 35 by 20. Then, how to write it in sketchbook? First, you are going to draw the XY line and you mark VP and HP. So, first you consider any point and draw a perpendicular line to the XY line. Then you measure the distance of 20 mm and mark this point. So, from here you measure 35 mm and mark this point. From here you measure 20 and you mark this point. And from here 35 you mark this point. Then mark A, B, C, D. Then draw a perpendicular from A and D, vertical projector from A and D to the XY line. Similarly from B and C to the XY line. So, as we look from the front view, AB is near to the observer. So, A dash B dash is visible and C and D is away from the observer. Therefore, C dash D dash is invisible. So, it is kept in bracket. Then join A dash to B dash with a dark line. So, this is how you will be able to write the initial position of the square in the front view as well as in the top view. Since all the sides are resting on HP, so this will going to be the true shape. That is AB is equal to CD which is 35 mm and AD is equal to BC which is equal to 20 mm. So this is how we will be able to write the initial position of the rectangular lamina by using the sketchbook. Now we will go for the next position. The lamina is rotated such that till it appears as a square in the top view. So he has not mentioned what is the side of the square, but still he says it is a square. How do I be able to get that it is a square of 20? So that is my question. So in our previous videos what we did, we used to take the shorter edges resting on HP, then he used to give the inclination with respect to HP, then you need to transfer from here to here and then you cut it on this, then you project to get the top view. But in this case, he has not done like that. The lamina is rotated till it appears as a square in the top view. So which is the side which is resting on HP? One of the shorter edges is resting on HP. So that is B dash C dash. In this case, what I have done is B dash C dash is resting on HP. So what is the side of the B dash C dash? As B dash C dash is parallel to HP, so you are getting the true length in HP. So what is the length of B dash C dash? That is BC, which is equal to 20 mm. Once you get this side is 20, so the lamina is being rotated till it appears as a square in the top view. So one side is 20, so obviously other side is also should be 20 only. Then only it becomes a square. Therefore, you construct a square in the top view first. Okay? Then you project this to the front view. Then you measure the distance from here to here with B dash center, cut an arc on that vertical projector. So that you will going to get this point A dash, and then join A dash, B dash, A dash and B dash with a dot line. So this is the surface inclination with respect to HP, what you will going to get in the vertical plane, that is on VP. So in this particular position, you can see the surface is inclined to HP and perpendicular to VP. Now, the side which is resting on HP is parallel to both HP and VP. So that is the condition. That is the one which we need to say. That is what he says. The edge on which the lamina rests being parallel to both HP and VP. So which is the edge which is resting on both HP and VP? The edge which is resting on HP is B dash C dash. So what is the position of this B dash C dash with respect to HP and VP? Now how to write this in the second position? Let us see. Now here, once you do this, then draw a horizontal projector from C and D and also from B and E, and consider any point from here. You draw a vertical line and you mark this point as B and C. So you mark this as B and C. So what is the position of this? The position of this is 20 mm. So from here you draw a vertical projector. Okay, you mark this point which is B dash and C dash in bracket. Now as we know, this is the point which is the parallel to HP. So therefore you are getting the true length in HP. So this is BC is 20. So once BC is 20, the square will going to have another side is also equal to 20. So from B you measure 20 mm and you mark this point. Similarly from C also you measure 20 and you mark this point. Mark these 2 points as A and D. Then join A to B, B to C, C to D and D to A with a dot line. Then from A and D you draw a vertical projector to the front view. Then by using the compass you measure the distance from B dash to A dash with B dash C dash as center, cut an arc on the vertical projector. Then you are going to get this point as A dash and D dash in bracket. Then join A dash B dash with a dot line. So now we got the surface inclination with respect to HP. And here what is the position of the surface with respect to both HP and VP is the surface is inclined to HP but perpendicular to VP. Therefore in vertical plane you are getting a line. Okay. Now once you get this, what is the position of this B dash C dash? The position of this B dash C dash is parallel to HP but perpendicular to VP. BC is perpendicular to VP. Therefore you are getting a point. But what he says, the edge which is resting on HP is parallel to both HP and VP. Now here we have the line parallel to HP but perpendicular to VP. Since I want in the top view also you have to get parallel to VP. What should I do now? You have to rotate such that the BC will going to become parallel to XY line in the top view. So what should be the rotation angle? It should be rotated by an angle of 90 degrees. That means you have BC at 90. When you make the angle of BC is equal to 0 degree, then it becomes parallel to XY line. So to do that, so what I am doing is I am rotating this inclined surface which is inclined at some angle being rotated such that BC is parallel to XY line or parallel to VP also. You can see that you are rotating in counterclockwise direction, that BC will going to be parallel to VP. So when you look from the top view, both B and C are equidistant from the vertical plane. Now the line is parallel to VP. Then what I am doing is I am rewriting the same sketch by rotating at an angle of 90 degree with respect to BC. So BC will going to become parallel and AB which was parallel will going to become perpendicular. Then AD which is perpendicular will also becomes parallel to VP. Then CD which is parallel to VP will become perpendicular here. So once you get this, so now when you look from the top view, you got these 2 points. So therefore this is also a square of 20 mm. So then when you look from the front view, these have been projected to get the surface here which is of some side, wherein you draw a perpendicular from D and you draw a horizontal projector from A dash and D dash, and you draw a perpendicular from DA, you got A dash D dash. Similarly, you draw a perpendicular line from B and C, and B dash C dash is on XY line. Therefore, B dash C dash is on XY line, and C dash D dash and B dash A dash will going to be having a vertical. So you can see that the side which is resting on HP is parallel to HP, and also it is parallel to VP. But what happens is with respect to the profile view, as the surface is inclined to both HP and also VP, therefore in the profile view you will going to get a line. So that is what we have shown here. So here draw a vertical projector from A and D to the profile plane, draw a vertical horizontal projector from here, and from here both these two lines will going to intersect at this point. As we look from the left side view, the image on the right profile plane will be D double dash is visible and A double dash is becomes invisible. Similarly, draw a vertical projector from B and C to the XY line. Similarly, from B dash D dash you draw this, you will going to get this point. As C is nearer to the observer, C dash is visible and B is away from the observer, so B dash double dash becomes invisible. Then join between D dash, D double dash and C double dash, you are going to get a line. Since you are getting a line in the profile view, therefore this will going to be perpendicular to the profile plane. You can see that these two are at 90 degrees. So you are going to get a line. So the surface is inclined to HP here, which is theta, and the surface is inclined to VP here, which is phi. So this is how you will be able to get the position of the surface in the profile plane. When the surface is inclined to both HP and VP, obviously that surface has to be perpendicular to profile plane, where I can see the inclination with respect to HP and also inclination with respect to VP together. But here you can see only with respect to HP, you will not be able to see the inclination with respect to VP. So why I am taking the profile view, because he has asked to find out the surface inclination with respect to both HP and VP. The surface inclination with respect to both HP and VP will be visible only in the profile view. That is because when the surface is inclined to both HP and VP, obviously that surface will going to be perpendicular to the profile plane. So you are going to get a line in the profile plane. So this is the reason. So this is how you will be able to analyze the dimension, analyze the problem in 3D. And how do I know that my problem is right in this case? You can see the edge which is resting on HP is parallel to VP, and parallel to HP. Okay, and the surface is inclined to HP and the surface is inclined to VP. And the edge which is resting on HP is rotated about the edge such that the surface is in the top view becomes a square, and it is one of the resting on one of the shorter edges. So B dash C dash is the edge which is resting on HP, which is a shorter edge. Now how to write this in the profile, in the orthographic view? So what I need to do, the edge which is resting on HP is parallel to HP but perpendicular to VP. You make that line parallel to VP also. That means you are rewriting the same sketch by rotating at an angle of 90 degree with respect to the original one. So that means B and C will going to become parallel. This perpendicular line will going to become parallel. This parallel line will going to become perpendicular. Here CD is parallel to VP. So here CD becomes perpendicular, and DA is parallel to VP, and AB is perpendicular to VP. So now if you are considering the side which is resting on HP, that side is also parallel to HP and this side is also parallel to VP. So rewrite the same sketch by rotating at an angle of 90 degrees. AB, which was horizontal, will become vertical, and BC, which is vertical, becomes horizontal BCD. Now we have to write the front view. How to write the front view? Draw a vertical projector from A and B to the front view, and also from D and C to the front view, and draw a horizontal projector from A dash and D dash. A is on this side, so A dash will be here, and D is on this side, so D dash will be here, and then B is here, so B dash will going to be here, and C is here, so C dash will going to be here. So dot them between A dash, B dash, B dash, C dash, C dash, D dash, and D dash, A dash. Once you get this, now I need to write the profile view, because this is the surface inclination here. In this top view and front view, you are not able to get the surface. You are not able to see the perpendicular surface, because the surface is inclined to both HP and VP. In this case, the surface is inclined to HP but perpendicular to VP. Therefore, you are getting a line here. But here, the surface is also inclined to VP, and the surface is also inclined to HP. So therefore, it is the surface inclination is both with respect to HP and VP. Obviously, that surface will be perpendicular to profile plane. As you look from the left side view, you can get a line in the right profile plane. So this is the right profile plane. What I am doing is, so from you take any convenient distance and draw a x1 y1 line, and then with reference to this origin, you measure an angle of 45 degree and draw an inclined line. Then draw a horizontal projector from A and D to the 45 degree line, and from this line you draw a perpendicular to the profile view, and since it is the projection from A and D, draw a horizontal projector from D dash and D dash. Both these two lines will going to intersect at this point. Since this is the right profile plane, I have to look from the left side to get it onto the right profile plane, and D dash is near to the observer, so D double dash is visible. A dash is away from the observer, so A double dash becomes invisible, it is in bracket. Then similarly, draw a horizontal projector from B and C to the 45 degree line, and draw a vertical projector from this point to the profile view, where B dash C dash is on XY line. Therefore, these 2 points will going to intersect at this point. You mark that point. As we are looking from the left side to write it on the right profile plane, so C dash is near to the observer, so C double dash is visible, and B dash is away from the observer, so B double dash becomes invisible, so you keep it in bracket. Then join between C dash and D double dash, C double dash and D double dash, which will go to become a line. So that is what we have shown here, which is the same line. Since for the XY line, it is the inclination with respect to HP. For X1 Y1 line, it is the inclination with respect to VP, which is 5. So by using the protractor with reference to this horizontal XY line, you measure the angle in the counterclockwise direction, which is theta, which is 55 degree. The sum of these two will be always equal to 90. Therefore, 90 minus 55, 5 will also be equal to 45 degree. The sum of theta plus phi is always a complementary angle, which is equal to 90 degrees. You should bear it in mind. So this is how you will be able to write the solution by using the sketchbook. But how to know my drawing is right? You can say that the shortest, it is resting on one of the shortest edges, that edge is parallel to both HP and also parallel to VP. And the surface is inclined to both HP and VP, which is been quite evident here. It is rotating on one of the shorter edges, which is the short edge what we are talking about is BC. BC is the shorter edge because BC is 20 and AB is 35 is the longer edge. So it is resting on one of the shorter edges on HP till it appears as a square in the top view, which is, since this side is 20, obviously the other side is also 20, the square of 20, and then it is a side of a square rectangular lamina of 35 by 20 mm. So this is how, since we have considered all the data which was given in the problem to solve this solution, and hence our problem is right. Thank you.